In this session, we shall see about different types of leukocytes, that is WBC cells, and then later we'll also see about the blood groups. So now first, let's begin with this WBC cells, which we also call it leukocytes, and these leukocytes are colorless and they are nucleated. So when we see in the case of RBCs, when they come to maturation state, we understood that they will not be having nucleus, but these WBC cells will have nucleus throughout their lifespans. And then, right, so WBC cells, their number is relatively less. So leukocytes number is relatively less when you compare with the RBC or any other type, okay, of cells. So here I'm comparing with the RBC. If you are comparing these WBC cells with the RBC, so in the last session I told you that, okay, RBC, okay, is to WBC ratio is 700 to 700 is to 1. So in this case, we understand that the leukocytes number is very less when compared with the RBCs. Then the leukocytes have short lifespans. So I'll give these lifespans, okay, basing on the type of WBC cell. And now we know already in the yesterday's session we have seen these leukocytes. We classified into mainly two types, granulocytes and agranulocytes. Okay, so the granulocytes are the one that have granules in the cytoplasm, and agranulocytes will not have right granules in the cytoplasm. So basing on that, we classified into these, okay, granulocytes and agranulocytes. And already I have told you that these granulocytes are also called the polymorphonuclear leukocytes. So in short, PMNL is the word that we have used. And okay, so these are of different types which we have seen, right? So they are called eosinophils, right? So these eosinophils, and then, okay, basophils, basing on their response towards the dyes they have used. If they have responded, okay, to these acidic dyes, then eosinophils, then basic dyes, then basophils. If they don't respond to acidic and basic dyes, then neutral, so they are called neutrophils. Okay, so we'll see about them, right? Then we know the agranulocytes, which we classified into those lymphocytes, and then the monocytes. So first we'll go with this, okay, granulocytes. First we'll see about these eosinophils or acidophils. Okay, so here they constitute 2 to 3% of total leukocytes. 2 to 3% of total leukocytes, and their lifespan is around 2 to 5 days. The lifespan is 2 to 5 days, and they have a characteristic bilobed nucleus. They have characteristic bilobed nucleus, right? So here you can see this is a bilobed nucleus, and all these are granules. So bilobed nucleus, and these are all granules. Okay, so the next one, this is how the eosinophils look like. Okay, and increase in the eosinophil number is a condition, we call it eosinophilia. Is a condition, we call it eosinophilia, and this eosinophilia is caused in certain conditions. Okay, so their number actually increases. So eosinophil number increases during allergic reactions. So during allergic reactions their number increases, and okay, during helminth infections. So during helminth infections also its number increases. Okay, then even during cancers, okay, or certain autoimmune disorders. So in, okay, etc., in such conditions the eosinophilia number increases. So the eosinophilia number increases in allergic reactions, helminth infections, cancers, and even, okay, in autoimmune disorders. So the next, these eosinophils also act as antigen presenting cell. So in short we call APCs. So in the immune system we'll see about this, what actually is this antigen presenting cell. So eosinophils will act as APCs, antigen presenting cells. Then they are also involved in destruction of, okay, the tumor cells. They are also involved in the destruction of the tumor cells. Okay, and a polypeptide called interleukin 5 that is actually produced by basophils. Okay, interleukin 5, so this is produced by basophils. So this interleukin 5 that is produced by basophils, okay, interacts with the eosinophils. So this one, okay, interacts with the eosinophils, and this will help in, okay, the eosinophils to grow and differentiate. So now the eosinophils grow and they get differentiate. So this is a small information on, okay, eosinophils. Then later we'll see about basophils. So these basophils constitute 0.5 to 1% of, okay, total leukocytes. Constitute 0.5 to 1% of total leukocytes, and the lifespan is around 3 to 4 days. Okay, so approximately all these values I am giving here. And the nucleus is divided into irregular lobes. It is actually based on the shape of the nucleus only we will be able to identify whether it is a acidophil, basophil, or a neutrophil. Okay, then So basophils release substances like heparin, okay, histamine, then bradykinin, etc. So heparin is an anticoagulant. So histamine involves in inflammation reactions, and bradykinin, okay, increases, okay, vascular permeability. So there are several functions, okay, right? This is heparin anticoagulant, histamine inflammation reactions, they are involved, and bradykinin is involved in increasing the vascular permeability, right? So here we'll see the structure of the basophils. So you may see something like this. So this is the nucleus, and all these are granules. So this is how you'll see the structure of basophil. It's a right now small information on these basophils. Right. Next one, we'll see about neutrophils. So these neutrophils, they constitute around, okay, constitute 60 to 65% of total leukocytes, okay, and the lifespan may range from 1 to 5 days. Then the nucleus is usually, so it is lobed, okay, so you will find around, okay, 2 to 5 lobe. The nucleus is 2 to 5 lobe. I'll mention instead of usually is 2 to 5 lobe, and I'll say usually 3 lobed. Nucleus is 2 to 5 lobed, and usually it has, okay, 3 lobes. Then these that's what we'll see the diagram here. So this is the nucleus. So all these are granules. So I have shown you here with the 3 lobes here. Next one, these neutrophils, these are phagocytic. So that phagocytic cells. Then these cells are highly mobile, and usually these are the cells that actually come to the site of injury first. So right, so this is some little information on the neutrophils. The next we shall see about the agranulocytes. So these agranulocytes, you know, it is of right, two kinds. one we'll see about these lymphocytes. Already I have given you the types of lymphocytes, and so we'll see some information on these lymphocytes. Now these lymphocytes, already I told that they constitute around 20 to 25% of total leukocytes, of total leukocytes. Then, right, so the nucleus in this case is spherical. So nucleus is spherical in shape. So if you see, you'll almost see the nucleus almost round in shape. Okay, so this is the nucleus, and the cytoplasm. You don't find any granules in the cytoplasm. The next one, okay, the lifespan. Some types live for few days, while some other can live for many years, so or maybe throughout the life. So that is the lifespan of these lymphocytes here. Okay, then that's small information on lymphocytes. Then next we shall see about monocytes. So here monocytes, they constitute around 5 to 3% of total leukocytes. I'm sorry, this is 6 to 8%, not 5 to 3%. So constitute 6 to 8% of total leukocytes. These are phagocytic, so just like those neutrophils, okay, these cells are also phagocytic, and their nucleus is kidney shaped. The nucleus is kidney shaped, so you can see here. So it looks like this. The nucleus, and this cytoplasm. So the nucleus is kidney shaped. Then the monocytes, after entering the tissues, so after they enter the tissues, they may get fixed in the tissues. Okay, so right, so after entering the tissues, these monocytes will become macrophages. So if they remain permanently in the tissues, then we call fixed macrophages, or if they are moving all over the body, then it becomes wandering macrophages. Then the lifespan of monocytes is around 10 to 20 hours in circulating blood. So that's all about these monocytes, and together the agranulocytes. The next one we shall see about thrombocytes. So they are the platelets, and these are formed from the megakaryocytes. I'll say megakaryoblast will become megakaryocyte, and that megakaryocyte in bone marrow. So this takes place in bone marrow, that results in the formation of these platelets, right? So here the platelets are cytoplasmic fragments of megakaryocyte. So if you see, okay, so this is the megakaryocyte. So okay, so here this megakaryocyte will give rise to the cytoplasmic fragments. So you can see here the megakaryocyte, and these are the platelets. Okay, right. Then the less count of platelets. So less count of platelets is a condition we call thrombocytopenia. Thrombocytopenia is a condition where there are less number of platelets. Okay, and there may be increase in the platelet count also. Then the condition becomes increase in platelet count. So increase in platelet count is a condition called thrombocythemia. These platelets help in hemostasis. It helps in hemostasis. The meaning of hemostasis is prevention and stopping of bleeding. So I say, okay, preventing bleeding. The meaning clotting of blood. So that's all about these thrombocytes. The next one we shall see about blood groups. So here the blood groups were discovered by Carl Landsteiner. So the person is also called the father of blood groups. Carl Landsteiner discovered the blood groups in 1900. So he is also called father of blood groups. Then, right, so according to him, there are 4 blood groups in humans. So that is AB, right, O and B. So are the different blood groups we have. So A, B, AB and O are the different blood groups, right? And now when we see here, according to ISBT, International Society of Blood Transfusion. So according to International Society of Blood Transfusion, we have around 33 major blood groups, which also includes this ABO blood group system, and another common blood group system which we will be studying in books is also MNS blood group system. So we'll see, okay, especially this ABO blood group system. So another one we have is MNS blood group system. I'm not discussing about that MNS. Okay, I think so. Another one is MNS blood group system. This I'll not discuss, especially we'll go with this ABO blood group system here. Then right, the genes for ABO blood group are present on chromosome number 9. So they are present on chromosome number 9. Okay, so the genes for this ABO blood group, they are present on chromosome number 9. Then here I will also give you some other information, and the genes for RH blood group. So for ABO blood group it is on chromosome number 9, and for RH it is on chromosome number 1. So this one, the genes for the RH, okay, factor, they are present on chromosome number 1. Then I'll also give this information for MNS blood group. So that is, those genes are present on chromosome number 4. So genes for MNS, they are present on chromosome number 4. Then, and one more information, the antibodies involved. So the antibodies involved in ABO system. So the antibodies involved in this ABO system will be including the IgG and IgM. IgG and IgM are the two immunoglobulins that are actually involved, okay, in this okay, ABO blood group system. I'll write again. Antibodies involved in ABO blood group are IgM and IgG. So later I'll discuss about the erythroblastosis fetalis. So at that time one point will be helpful. So out of these two immunoglobulins, IgM and IgG, IgM cannot pass through the placenta and enter the fetal circulation, whereas IgG can pass through the placenta and enter the fetal circulation. Okay, so that I'll mention here. IgG can pass through placenta and enter, okay, fetal circulation. So here the type of antibodies involved in erythroblastosis fetalis or responsible for erythroblastosis fetalis, then there are IgG antibodies. Okay, so there are IgG antibodies. So this is information, small information on the blood groups. So now let's see the different types of blood groups. So here the blood groups are determined basing on presence or absence of antigens on okay, surface of RBC cells. So there are certain types of antigens present on the surface of RBC cells. Based on their presence or absence, we will determine what type of blood group the person is having. The blood groups are not determined based on the presence or absence of antibodies. So here, whereas antibodies are present in plasma, so they are present in plasma, whereas antigens are present on the surface of these RBCs. Based on this, okay, the antigen, what antigen it is present on RBC, basing on that only we will okay, classify the different types of blood groups here. So we have four, okay, blood groups. So AB, I'll mention, so AB and O blood group. Okay, now in this case, the antigen present in case of blood group A, so the person who have blood group, antigen A will be the person with the A blood group, and the person with the antigen B then is the person with the B blood group. And if the person is having both antigen A and B, so the person is having antigen A and antigen B. So if I say here, okay, this is the surface of the RBC, the plasma membrane, okay, of RBC. From there, say, okay, so these are, right, the antigens. Okay, so in this case, okay, so this is an antigen A. So in that case, the person is said to be having, okay, A blood group. Okay, I think I'll write here antigen A. Now in the case of B blood group, these are antigen B. So that is B blood group. Right, so in another case, so this person is having on his RBCs the A antigens, and also the person is having B antigens. So this is antigen B and this is antigen A. So hence, right, so the person is said to be having, right, AB blood group. So if there are no antigens at all, so if the person is having, okay, like this, no antigens, either A antigen or B antigen, there may be some other, okay, but here we are talking about these antigens A and B. Okay, so in this case, this is the blood group. No antigens, that is antigen A or antigen B, that they are not present. So hence, okay, we call it as the O. So 0, right? No antigens A or B antigens, right? To antibodies, I said antibodies are present in plasma. So here antibodies in plasma. So the person who is having antigen A will not be having antibody A. So instead he will be having, okay, anti-B antibodies. And in this case, the person will have anti-A antibodies. And right, the person who is having this blood group A and B, they are the one who do not have any antibodies. So here I mentioned, okay, no antibodies. Then, so here the person with the O blood group, in this case the person is having, right, both the anti-A and also anti-B antibodies. Okay. Now let us look at the agglutination. Okay, so here the agglutination is nothing but clumping of blood. Okay, I'm sorry. Okay, agglutination is clumping of blood. So here this clumping of blood takes place right when recipients antibodies react with the donor's antigens. Okay, so this is what happens. The recipient's antibodies react with the donor's antigens. Here I'll give you like a few more words. These antibodies are also called agglutinins. Antibodies, we have another name. Okay, agglutinin. So agglutinin, or you can also use another word, isoantibodies. Isoantibodies. Whereas antigens, we use another word. Okay, agglutinogens. Agglutinogens or agglutinogen, or you can use another word, isoantigen. So other names for these antibodies, agglutinin or isoantibodies. Another name for antigens, agglutinogen or antigen. So as I have mentioned here, the recipient's antibodies will react with the donor's antigens. So now if you take say suppose a person with A blood group, okay, so he is a donor and recipient is B blood group person. So now in this case the person is having antigen A and antibody is anti-B. So in this person, the person is having antigen B and antibody anti-A. So when these donors, okay, blood enters into the recipients, so here we have this, okay, anti-A antibodies. So these anti-A antibodies will fight with this antigen A, and this is where the agglutination takes place, or clumping of the blood takes place, that results in, okay, the blocking of blood vessels and then choking of the heart, and then finally it results in the death of the person. So this is information on agglutination. Okay, so I'll give a table with this. Recipient, so we have A, B, AB and O blood groups. Then this is the donors, the blood group A, B, AB and O. Okay, so A to A, so the person can donate to A to A, so no agglutination in this case. Okay, then if the person is giving A to B, then okay, there will be right heavy agglutination. So here I just mentioned plus indicates, I'll mention here the plus indicates heavy agglutination. It includes a heavy agglutination. I think still it's not visible. I'll mention this. Plus plus indicates heavy agglutination. It indicates heavy agglutination. Okay, and the minus, this indicates no agglutination. So completely safe, 2 minus, completely safe, and the just 1 plus is okay, right. I'll say it's a light agglutination. So light agglutination. So those things which I'm going to use here. Then the A blood group person, okay, giving to AB. So here there will be light agglutination, and the A cannot give it to O at all. So hence, right, there will be heavy agglutination. Then B to A, not at all. So that is heavy agglutination. Then B to B, no agglutination. And B to AB, there will be slight agglutination. And then B to O, heavy agglutination. Then AB to A, no heavy agglutination in this case. Then AB to B, in that case also it will be heavy agglutination. And AB to AB, okay, no agglutination. And AB to O, you will see again heavy agglutination. And then O to A, okay, light agglutination. O to B, okay, so in case of light agglutination, the person can donate the blood, no problem. Okay, the recipient can take the blood. Okay, then O to AB, then in that case also it will be light agglutination. And O to O, no agglutination. So with this table we understand that this O, okay, it became the universal donor. Okay, and when you see here, this one, it has become the universal recipient. Right, fine. With this I'll end up here. In the coming session we'll see some more information, okay, on these blood groups, and even we'll continue, okay, to RH blood grouping also.